Hey guys, welcome to the Hewlett-Packard 8662A restoration series. A few days ago I unboxed it and stayed up late because I was excited and I wanted to see if I could get it working. And I was able to, with the help of a great detailed tutorial series on troubleshooting the power supply in these devices. Which led me to go straight to this board where I discovered some charring and replaced these two caps temporarily. That didn't fix it though, or that may have been a part of the equation because the caps that were there had a little bit high ESR, but the real culprit that was preventing this from working at all was this cap. This is the controller board for the switched mode power supply. I don't know exactly what that cap does, but I suspect it was preventing the oscillator circuit from working properly. Off the main transformer there are plus and minus 160 volts that go into this board. These round things, these are transformers. And on the back side we have some switching, I think they're transistors. I don't think they're MOSFETs, I think they're transistors. So this controller board sends control signals to these transistors, which turn on and off and pump power into the primary of this transformer. And I don't know if these are just like filter inductors or if these are transformers as well. And then out of this we get a number of voltages. So the charring on this I thought was kind of curious. Let's check out where it is. It's there, 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 there. And you can see it really on the top as well. And on the board that this plugs into, the back plane, it was charring underneath that too, along the traces. And we're thinking, oh boy, this resistor must have really cooked. No, the resistor is fine. Where the charring is where the vias are, where it's going from one side of the board to the other. I suspect those must have higher resistance than the copper traces. So in other words, something was drawing a lot of current and it was going through these traces, and where it met a little bit higher resistance, that created hot spots. And that's what the charring was from. So none of the parts actually charred. The board itself got a bit charred and toasty. Okay, so we got to the point where it was kind of working. We have a clipped waveform. None of the modulation modes work. One of the rotary control doesn't seem to work as well. I received a bunch of comments, some of which I think will be very instrumental. For example, that rotary encoder, there are apparently incandescent bulbs inside rather than LEDs that are very likely burned out, so that could be why that's not working. Hopefully, by doing more work on the power supply, I might be able to fix the clipping issue, because I didn't actually go through and check any of the voltages. Again, it was late at night. I was exuberant that it actually turned on and did something. I need to go through it more methodically and check all the voltages and adjust them as needed. There are controls on this. Adjust minus 40 volts, adjust minus 10 volts, adjust plus 20. There's also a 5.2 volt, I think it's on this board, 5.2 volt trimmer. So, I reviewed that series again, in which he talks about each of these boards and the capacitors on them. He removes them one by one, he checks their ESR, and he shows the replacements that he chose to use. And he ordered them from Mauser, which is a place I commonly order parts from. And the video is not too old, it's less than 2 years old, I think, so most of those parts he spec'd out are still available. However, I wanted to point out a few things. One, there is a brand new line of axial capacitors that has really good specs. That's a really unusual thing these days, because axial caps, where the leads come out the ends, have been rapidly disappearing from the marketplace because most things these days use caps that are vertically oriented. And most things these days run on lower voltages. So thankfully there are some devices that still use higher voltages. So certainly in the radial form, getting caps rated for 250, 300, 450, even up to 600 volts is really not that difficult. But when it comes to axial caps, choices are kind of limited. Yes, they do exist. There are MIEC, these guys, readily available for a number of vendors. However, I've never seen published specs on these. I suspect they aren't that great. For sure, they're only rated for 85C. I'm thinking that their ESR isn't so great. I wanted something better. Illinois Capacitor still makes some. Nichicon makes some. Sprague Adams are back on the market. It's kind of a boutique tube amp product. However, these are all rated for 85C. And none of them have particularly great ESR or ripple current handling capabilities. But I was looking on Mouser and they said, hey, there are these new Vishay caps. In particular, these guys. And then they have them in these cardboard carriers. These are good. Let's see, do I actually have the specs on one of them? Yeah, so 63 volt, 470. But those aren't the main ones I wanted. The ones that are kind of charred looking, that's where I wanted some really good caps. So here we go. 220, 400 volt. Yeah, they're still just 85C, but they're rated for 15,000 hours of life. They have really good ripple current capabilities and really low ESR. Why is somebody making new production axial caps? I looked at the data sheet and their applications. Oh, actually, some of them these are 105C. Some of them are 105Cs. Apparently these, maybe they're printing with them. I thought they were all 105C. Hang on. Let's take an actual look at the physical cap itself. Yeah, 85C. Even so, they have really good specs. So why is somebody making these again? Apparently industrial lighting, LED lighting applications, which is why the radial ones are being made generally as well. So if you bust open some LED lighting fixtures, you'll find Nichicon skinny caps. Those ones I've been using in the adapter caps, for example, they made them for lighting fixtures. Apparently that's what they're making these for again as well. Now, if you watch the video for this, for these caps, he gets some 450 volt caps, and he's saying, oh, because they'll have lower ESR. That's not true. The higher the voltage you go, typically the higher the ESR. Why? Because there's more stuff between the conductive surfaces to get higher voltage by spreading out the distance between the plates and using a different electrolyte formula. That increases their effective series resistance. The originals were 250. I wanted to get something more robust, though, because these are known as having an issue. So these were the best caps I could find. They're not horribly expensive, $5 a pop or something like that. They should fit. I might have a little bit of trouble, but I'll do the best I can. These guys, I got caps very similar to what he ordered up. These guys, I think he used Sprague Adams for these, but I ordered up these guys, the new Vishay caps, and these are 105C. I'm not sure why, because they're all the same product line. I just assumed that they were all 105C, but apparently they're not. But at any rate, the only downside to this is if you look at the data sheet, they come in a wide variety of voltages and capacitances. But at Mouser, at this point in time, they only have maybe a dozen or 20 different varieties of voltages and capacitances to choose from. So somewhat limited in what you can get. I think I wrote up a better cap for this. I just happened to have a nice axial Nichicon. This is the one that failed. It was completely open. I think I have a little bit better one I'll be using for that. Now these guys, all these silver guys, a little blob on one end, these are tantalum. In his tutorial series, he just ignored those. However, when we get to this board, one, he had slightly different caps on his board. On his, I believe these two were identical. On mine, they look different. This is tantalum. These two are also tantalum. He replaced these with electrolytics. And I don't know if he didn't realize they were tantalum or what. But what threw me off is I looked at the specs. It's an 82 microfarad, 75 volts at 85C, and 50 volts at 125C. And I've never seen electrolytic caps where they give you the voltage they can handle varies with the temperature. That seemed really odd to me. Also, this is a lot of capacitance. In a very small package, I couldn't find something that was 82 or 100 or thereabouts for 75 volts that would come anywhere near to fitting in this. So I'm going to leave these alone. I got advice from a number of you guys, just leave the tantalums alone, they'll be fine. That's what all these are. Plus it would cost a fortune if I got real tants and replaced all those. That is an electrolytic, it's Sprague, so I am going to replace that. It's the only thing I'm going to replace on this board. So my hope is, by replacing all the electrolytics on these three boards, we'll pop it back in. Maybe I'll have to tweak the voltage rails. That may improve my clipping situation. The waveform may be clipped, in other words, because the power supply is off. If not, well, then we keep going. Now, there are a few other caps. There are some big screw lug caps for the plus minus 160, and the one on the what eventually becomes the 5 volt rail, 5.2 volt rail. I'm not replacing those at this point in time. For one, I couldn't find them. And he mentioned, too, that he had a little bit of trouble finding them. But even if I could, we're talking $50 or so a pop. Or I could get something like snap locks, but they would not line up with the mounting holes, and they wouldn't be screw lugs. So I thought, okay, before I start butchering the board or having to make some kind of bodge or something, let's just go with the parts that I know will fit on the boards and such, and see how that works out. So, before we leave off, a word about the temperature rating. I've been saying 85C, 100C. That's Celsius. 100 degrees Celsius is the boiling point of water. And you might be thinking, this thing isn't going to, nothing should ever get that hot. Why would you need caps rated for that high? True, it'll never get to be 105C, and it shouldn't get anywhere near that with the cooling fan running. But temperature is the death of caps. Their lifespan is an estimated lifespan formula you can find in the data sheets. It has, I believe it's an exponential factor tied to temperature. In other words, the hotter it gets, it rapidly shortens the life on these. So if you get higher temperature caps and run them cool, it should last for a very, very long time. So when I said these are 12 or I think it was 15,000 hours at 85C, that means if this was at 85 degrees Celsius, they would last 15,000 hours. If you run it at room temperature, and like I say, it's an exponential factor, these should last hundreds of thousands of hours. Now, there are other factors, too, so that you don't necessarily going to get that much life. The voltage applied across it is also another factor, but temperature is by far and away the dominant factor for how long capacitors will last. You can even get 125C if you really want to spend some money. So the higher the temperature rating and the cooler you run them, the longer they will last. Let's check the ESR on one of these lovely new Vishay caps before I install it. The originals had, one head was 6 and one was 12. 0.28. Lovely, lovely, lovely. Let's check out the ESR on these lovely new Vishay caps. The two originals that were in this position measured 6 and 12 ohms, as best I recall. And these guys are 0.27. Nice, nice, nice. More than a factor of 10 lower. Good stuff. Let's also check one of these guys. There'll be 4 of them going into this board. 470 microfarads, 63 volts, 105 degrees C rated. .11 ohms. That is outstanding. The rebuilt boards are ready to be reinstalled. I tested all the caps I removed. This one is completely open. It's the one that was preventing this device from working at all. These 3 are very high ESR, between 5 and 12 ohms. So hopefully replacing those will help. We knew these were high from the previous installment. This guy was this one, and this was pretty high too. It was around 6 or 8 ohms. So we'll see what it does. So I'll clear the decks, get that back up here, pop in these boards, and fire it up again. The boards have been reinstalled. I have it plugged in, hooked up to my scope. So let's give it a try. Notice the power switch is a little flaky. Had trouble with that before. Hey! Hey! Remember we had a little error light on the AGC board before? We do not now, and we do not have a clipped sine wave anymore either. How about that? Too good to believe. Looks a little fuzzy too. And it should, because I have FM modulation turned on. Mod off. Oh, it's still fuzzy. Maybe my scope is not triggering. Huh. Well, that's a little odd. Oh. Oh, man. Oh, the error light came back on. Well, it was good while it lasted. Let's try amplitude modulation. Yeah, I'm inspect status error 10. Well, interesting. Well, next up, I noticed that next to each of the adjustment points for the power supply, there's a little gold stake that sticks out, and they're labeled test point. So I think it's a pretty good assumption that those have the voltages, like plus 20, minus 10, that we need to check. I have my new voltmeter fired up, so let me connect that up and see if any of those voltages need adjusting. Well, all the voltages are about as dead on as you can get. For example, here's the 5.2 bus. We have 5.1987. Okay, I guess I could tweak that a tad. The rest are even more close. You do get pretty nice control with these little trimmers. I think that's good enough. Alright, so that, unfortunately, the power supply is not the source of our trouble. So, now there are trimmers on this. AM level, CW level, external offset, offset DA, AM and FM, DET, and internal level None of the modulation's working, so I don't think that's going to quite fix it. It is tempting to check the offset, because it seems like, well, it's being clipped because the DC offset is wrong. So let's do a couple things here. One, let's ground the input so we know what our reference line, where it's at. And let's get this dead on, so now we know that 0 volts is right in the middle. If we DC couple this, I was hoping maybe it was asymmetric, but no, it looks like it is pretty symmetric, and it is being clipped off at the top. So we could very well have a bad component on this. I've pulled out these 2 boards. They are loaded with stuff. No electrolytic capacitors. It's not going to be quite so simple. We could have a bad semiconductor. We could have a bad something. I spent the last 24 hours or so doing research, looking online, in various groups, looking at other YouTube videos, studying the service manual, looking what's available in terms of replacement parts, and trying to make some decisions. So let me get you up to speed. So recapping did not fix the problem. It seemed like it did for a moment, but ever since then, when I turned this device back on, it's immediately error code 10, the clipped output, no AM modulation, and only coarse amplitude control. Exactly the same problem I've had since the day I got this. So where do we go from here? Well, let me tell you a few things. One, when it comes to troubleshooting, you can't, as this stands, behind these screws and these handles, there are circuit boards. You need to probe them to troubleshoot it while it's turned on. If you want to check voltages and waveforms, you can't, unless you buy the extender kit, which are circuit boards about yay long, which just have traces running straight through with an edge connector and then a card connector on the other end. So you take your card out, you put the extender in, and you plug your card into that, so your card will be sitting totally exposed outside the device. Seems to me with some of these that could be a problem, because these little jumper cables are going to be way too short if you leave one card in and take another card out. And also there won't be any shielding. But luckily for this particular card with the red LED on it, to 10 error code, there are no coax connectors going to it. So out of all of these, I think it is the single easiest card to have extended out. Now those extenders, I have not seen a full set of the official Hewlett-Packard ones for sale, but there is an enterprising gentleman who has made scores of them for all sorts of different models, where he just etched his own circuit boards, and he calls them a kit, because you have to do some soldering for the new edge connector. I might buy a set from him. There are different card widths, so I think there are 5 extenders you need in total to handle all of these. I think the one I need in particular is 18. I'll show you this card in a moment. All right, let's talk a little bit about what the actual problem is. So the waveform is clipped at the maximum extent, like the upper 15%, 10% is clipped off. AM modulation does nothing. This has an internal AM modulation. You can pick 400 hertz, 1 kilohertz. It defaults to 30% modulation. You can dial that up. I have not tried all of that. I've just tried turning it on with the default 30%. I should try increasing that up to 99 and see if it ever kicks in. But also FM modulation doesn't seem to be working, which is a totally different mechanism. One is varying the amplitude at the output stages, and the other one is varying the frequency, which I find odd because the sweep works. And I would think they would use the sweep circuitry to do the FM modulation, but I could be wrong. However, in the same 10 module here, there are trimmers or adjustments for both AM and FM. So I haven't fully studied how the FM portion of things works, but there are 2 cards that comprise of this. There's only an error light LED on one of them. The other has no provisions for an error light. but I think it's more likely the error is on this. The one that has the error light does the AGC, automatic gain control. The one that's sistered to it is the modulation. So after spending a couple hours looking at the server's manual, which is hundreds and hundreds of pages, I'm mostly focused on this. It does a few things. One, you want your output level to be what you specify. More low-level analog devices you just have an output level knob and you just turn it and you get what you get. But in this, you tell it, I want 0.15 dBm output, regardless of the frequency. That's what I want the output to be. Well, in order to maintain that, this has an RF detector that actually looks at what am I outputting, and it feeds it back into itself and adjusts the gain in this module to keep that output level at what you want it to be. So if your, say, load increases, it'll boost the gain, or if the VCO starts to lose its output level as the frequency increases, it'll compensate for that. Now, not only can you specify the output level, but if you have AM modulation turned on, that's also going to vary the output level. So they do both of it in this module. They combine both the output level you want with potentially AM modulation. The combination of those signals controls the output level of this device. Now, this can only do so much. Think of it as a voltage-controlled amplifier, but it has a limited range. The output of this device is a huge range of, say, it's minus 100 dBm to plus 10 dBm. That's logarithmic, so that's a range of 10 to the third power, 10 to the fourth power, something like that. A voltage-controlled amplifier is not going to have that kind of range. That's why you hear a relay clicking in. At some point in here, there's going to be some type of bank of relays or something simulating a rotary switch. Again, on typical analog generators, there'll be a course level. We might have low, medium, high, and then there's a variable potentiometer to fine-tune the output level. This does that too, but it does it for you. The course is working. The fine is not. So at first I was thinking, well, the output attenuator either has to work or it doesn't work, right? But it's done in two different places. There's the course that happens on a separate board. It's the fine that doesn't work. So it makes sense that this board could be responsible for all the problems we're seeing. The clipping, because maybe it's sending the wrong type of, or it's over-amplifying it and clipping it. And the amplitude and the level I put in, the fine level control, they're just being ignored. Like this thing is pegged to max output level in here and only the course works. I'd have to look. I was a little confusing about what that error light actually means, other than something's not right in here. There's a lot going on in there. Which leads me to my other problem, or thinking, okay, even if I had the extender, and yes, they have test points, you can check for this voltage here and there, you can jumper out some things, you can dial in certain settings to see how it responds. It's complicated, but I think with a little bit of patience, I could work my way through it. However, even if I find some stuff doesn't look right, it's a matter of how do I fix this thing. There's house-numbered parts. The parts are very small. Some of them are kind of specialty parts. So even if I knew that, okay, this op-amp and this integrated circuit are bad, I got to source them. Nothing is socketed. So I went looking. There are guys who have parted these out. Maybe they're one that couldn't be fixed. There wasn't worth fixing. So they took the boards out and sold them on eBay. Somebody had one of these boards listed. $110, or make an offer. I got them down to, I think, 102. Not a huge discount, but I bought it. Not guaranteed to work, I don't think, but it looks okay. I don't know what'll solve my problem, but time is money, and to buy the extender boards and spend hours troubleshooting that board, to me, is worth $100, $110. If I could just swap in that board and it fixes the problem, hallelujah, save myself a lot of aggravation. If it doesn't, then we move on. Now this board next to it, the sister board, and there is not, I could not find one of those for sale. So, worst case, if that's not the problem, and I later do solve the problem, I can check both boards, and if they're both still good, I'll just list it right back on eBay and say, hey, it's been tested in a working unit, it's a good board, and I can probably recoup my money. So, at this point, I'm going to demonstrate the clicking and how the amplitude changes, and then I'm going to button this back up until the replacement board arrives. If the replacement board doesn't fix anything, I'll order up the extender boards. I think they're $25, but then you have to solder them yourself, and then we can proceed to do some troubleshooting. After I turn this on and demonstrate the clicking, I'll pull that board out and give you a look at it as well. So let's fire this guy up. So immediately we have the error. Now when I change the amplitude, I do that by doing amplitude, and then I can use these up and down buttons. Listen. Click. Click. Now look at the scope and listen for that sound. You'll see the amplitude only changes when you hear the click. So I'm going to go down, click, click. In between here, the numbers going up and down on the display. I'm going up, I'm going down. The output amplitude is not changing until you hit a certain point where it clicks. So we have coarse amplitude, we now have fine amplitude. Now you won't be wondering, or at least I was wondering, can I just use this as is? At least for doing some type of alignment or demonstrations, whatnot. Kind of. So yeah, I can sweep, I can dial in a frequency, I can do a coarse amplitude adjustment. However, that is going to induce a lot of spurious stuff outside my frequency. And also I'm noticing now the sine wave is kind of distorted. Try a lower frequency here. Make sure it's not my scope that's making it. Yeah, it looks better here. It might be the scope is distorting it a bit at higher frequencies. That does look pretty clean. But that is bad. If it was just maybe the upper tip just clipped a little bit, if I feed that into something and try to check the frequency response, there's going to be a lot of frequencies outside of 1 megahertz. And I just picked up a tiny SA spectrum analyzer, and we can check that out, which I'll also demonstrate. But I'm going to leave off now with a look at that card that I think is causing these problems. To get these cards out, they have little star screws on them, and sometimes you have to undo some of these coax connections, which are actually fairly easy to get off because you can just do this a little bit and then it loosens it up, and then you can just use your finger and undo it. This one doesn't have any connections going to it, but this one gets in the way of me being able to remove the card. And then you simply lift up and out of the way. And then we unscrew all of those screws. I think I left a few out from when I was playing around with it, so I just have a little universal tool here. Or I mean, I bought one of these iFixit kits that has just about every type of bit you might want to use. They're fairly long, so you have to screw quite a bit to get them out. Yeah, that's it. Just put 2 of them back in. Of course, careful to save all the screws. And voila. So, yeah, so right off some of these, like that house number. I know from looking at the schematic that that's a digital analog converter. And it's a CMOS, and they tell you to be careful with handling that so you don't zap it. But it's probably a DAC 08 or something like that. But what about that? Don't know. These are some type of op amp. Don't know. I did check all these tants. None of them are shorted. So that's about all I can really do with this. I tried checking a few of these resistors. Two problems. One, they're incredibly small. Two, the stripes don't make sense to me. I think some of these might be inductors or capacitors. I don't know, I had a hard time. The ones that look like 100 ohm, those checked as 100 ohms, but pretty much everything else, the value that I thought was based on the stripes is not what I got. So that's when I just stopped. The switch, that is used for troubleshooting. So the one I ordered looks absolutely identical to this, hasn't been monkeyed with, no charred traces or anything like that, so we'll see. So I'll button this back up and put it aside until the replacement board arrives, probably in a week or so. Of course, if any of you have seen anything like this before, have any advice, I am very open to it. I couldn't find anybody anywhere that has had this exact problem, so lucky me. Meanwhile, I did just buy this, which just arrived today. It's a it's a tiny spectrum analyzer. After I button this up, before I put it away, I will fire it up so I can demonstrate what having that clipped waveform does in terms of the spectrum of that output signal. But that'll be in a separate review video on this guy. Thanks for watching.